In this lesson for BobCAD-CAM, we're going to cover how to configure a head table machine configuration, but in this case our head of our configuration is a nutating axis. You can see what nutating means is the axis is not aligned to any existing axis like the X, Y, or Z. In this machine I have on the screen here, you can see if I rotate it around, our rotation axis is actually on an angle in the Y and the Z. And if I rotate that, you can see how it moves around there. There's also a C-axis, which is the table, and we'll configure that one as well. But we have to pull some numbers, just like any of the other machine configurations, off of this machine to know how far to set the travels and also figure out the position of the angle and the rotation point of the head. So we have to know a few things. The first thing you need to know is the angle from the straight Z of what that head is. In this case, this particular head is a 45-degree angle. What you're going to do at that point is you're going to take whatever your angle you find it to be and just find the sine of it. In this case, our value is 0.7071. So 45-degree sine is 0.7071. And we're going to use that when we define the direction around the Y and the Z as 0.7071 for both of those, so it defines where that axis is lined up, as you'll see. Now the rest of this is going to be just like a standard head-head configuration type where we need to take some measurements off of the spindle itself. So right now you can see I have in red here, I just made a quick little look of an indicator to show you how to measure off of this, and I'm going to turn the tool off in there because we want to pick up off the face of the spindle, the ground face, and then the outer ring is what we're going to use to get our measurements. So with the head at a 90-degree vertical stance, you're going to move it over, and then you're just going to bring it down until the indicator is zeroed on that face and record the number. We'll call that Z1. Then what we're going to do is lift the head up, rotate that axis 90 degrees. So my tool face is 90 degrees. We're going to bring it back down, and we're going to pick one of the rings of it. Like for this one, let's use this ring here. So you'll bring it back down. I've got to get it lined up here, see where I'm at. A little bit of the glare on there makes it tough to see. And you want to zero on the lowest point of this, and you want to get that lowest point to where you hit that same machine zero. So you don't want to move the indicator during this process. Once you have that, you're going to record that number as Z2. Then you're going to measure the diameter of this point of the spindle and cut it in half to the radius. Take that number and add it to the Z2. So that gets us to the center of the spindle when it's cocked over at 90 like this. Then you're going to take Z2 and subtract Z1 from it, and that's going to give us our rotation point distance from where when the head is sitting like this to this. And we're going to jot that number down, and that's going to be our rotation point, and then we have our sine of our angle of 45. Now if you don't know what that angle is of your machine, you might be able to get it off of the machine itself, but you want to be really accurate with that, so you can refer to the machine manual or contact the machine vendor if needed to figure out the angle that head is at. So once we have this information, we can go ahead and configure our machine. So let's close down this simulation. We're going to go to Milling Tools, Default, Current Settings. And under Machine Parameters, we're going to add a machine. And for this one, we're going to call it a V25 Training Head Table Nutating. And we're going to make it a 5-axis head table machine for this instance. If it was a head-head, it can still have a nutation and be a head-head, table-table, whatever you have. So now we've set that machine in here. So if we go to machine definition, you can see it gives us the basic layout of that machine. So we can just, like any of the other ones, start putting our travels and distances in here. So if we start with X, you have your ID, which is the X-axis. You want the 1 to be on whatever axis is the movement. In this case, it's the X. Now with this one, we need to think about what's moving. Is the tool moving back and forth in the X, or the table moving back and forth in the X and the tool stationary? If the tool is moving, it's a positive number. If it's stationary, it's a negative. So in this case, it will be moving because it's on the Z is on this one as well, and it's in the X, so we'll make it a 1. Now we'll set our travels, so we're going to do minus 20 and positive 20 for our travels in X. Now the way you get these travels is picture the head like we had it straight at the vertical of 90, and just the spindle face that we first initially indicated off brought down to the center of the table. Then you move the head up in a positive direction and record the numbers, and positive and minus in the X and the Y's as well. Let me go back over and show you that real quick here while we're talking about it, and then we can come back into that machine. So when this loads up here, what I'm saying with this one is if I turn all this off, all right, and if I zero all of them, see how it just brings the face right to the table? So you want to record in Z the farthest distance up from that position and how far it can travel down. Of course, virtually into the table you'll want to know. The same with the X, how far positive from that position and how far negative, and so forth. And those record those numbers off of the machine. Okay, so now we're going to go back in and actually set those travels to the machine settings again. So we're going to go to default current settings, make sure we have the right machine chosen, and go back to machine definition. You can see here this is where we set the X, and we put that minus 20 and positive 20, some distances we're going to use for the X and Y for this example. Now we're going to go down and do the Z. Now the Z is again the tool moving, so we're going to do a positive 1 in the Z. And for this one we're just going to use travels of minus 15 from the 0 and positive 20. So it can go up 20 inches from the spindle face on the table, and it can go down an extra 15 when it's rotated around on its side. Now my initial value is okay because it's in between those two numbers. I'm just going to center it more a little bit and bring it to 0. Now the B-axis, this is the one we want to take a look at here. And this is the one that we want to set up. And you can see these numbers that are in here. And this is what you want to put those signed numbers. So we're on B. And you can see that the Y is a minus 707 because that one's rotating but not the tool. It's just kicking it on a tilt. And the Z is the minus. Remember, it was cocked in the Z and the Y. And this is our rotation point number where we took the Z2 and minus the Z1 out and put those values in here. Now the travels are limited to 180 degrees positive and negative, so it doesn't hit. It can only go around to where we'll be sitting at the 90 and back the other way. So if you have limits on your rotations, you want to write those down as well. And our initial value is between those. So if I come down to Y, okay, we're on a negative here. You see how it set it up because it's on the base. This is not the tool moving. This is the Y moving on the base. So that's the negative 1 in the Y. And our travels here are going to be minus 20 and positive 20. And then we'll put the 0 between them. We're going to go down to the C. This is rotating around the Z axis. So we're going to make that a positive 1. And we're going to give it infinite rotations both directions. So we'll just almost infinite. We can go 100,000 each way before it has to rewind. That should be plenty. If you have a machine that only goes like 999 degrees one way, 999 degrees the other ways, you want to put those numbers in here. So that way when it hits that limit, the machine will stop cutting, lift the head, rewind the indexer back to 0, and then come back down and continue cutting from where it left off. And then your initial value. So once you have all those set up, the machine is built. You can come back and add geometry to the different machine components if you have those configured, and that is covered in another video as well in the set. So if I press OK, go to Milling Tools and Part to choose that machine for this example parameters. We're going to go down to the V25 HT training, Nutating. Now we'll go to simulation and see if we have the correct movement out of the machine. And like I said, this one doesn't have any geometry to it, so we're just going to see the tool moving. So we can turn those off and that dial indicator I have there. So you can see as I move it in the Y, everything's moving properly for me. I can see the travel distances here, 20, and the other way I get 20. Same with the Z. If I bring it all the way up, I have 20, and if I go all the way down, I have minus 15. So now I'm going to zoom out a little bit so we can see this. The C, you can see the part is spinning, which is the right position. And for this one here, you can see how the tool is going to move around. And perfect. So that lets me know my machine is configured correctly. And again, you can come back and add your geometry at any time once you have it all created and everything, or acquire it. So again, nutating head, table, machine. Nutating meaning that the axis of rotation is not aligned to any of the existing axes of the X, Y, and Z. So you use the sine of the angle to configure that. This concludes this lesson.